All right, so we just watched that wonderful video from Real Parse. That's a pretty good company, not company, YouTube video. They actually have a website to go along with this, which is really nice. So it's a great place for information for you guys. That is all linked on D2L. So if you need to go rewatch that video or read their website, you can. But right off the bat, what was Scada? Like, what does Scada stand for? It kind of touched on it. Not really, like, really well, in my opinion. It was long. Well, I mean, it is 5 letters. Cam, did you have something? No, okay. They touched this, but they never were like, Scada means. So, Scada means, I'll say it, supervisory control and data acquisition. That is what we've got going on. And we really have that kind of separated into 2 sections. We have the supervisory control aspect, and then we have the data acquisition aspect. You can have one without the other. So the data acquisition to me is overall like actually like saving all of that data and doing something with it. Maybe looking at it for real-time information in the past, looking at temperatures or whatever the case is. The supervisory control, that is definitely being used. All right, anytime you have a PLC, in theory, you're starting to do that supervisory control. Not necessarily. I mean, the PLC could be the supervisor, but you might not have something above the PLC. I know at some of our local companies around here that they have PLCs, but each station is its own little entity. It's not networked at all. So if you want to use that station, there's an operator sitting there loading it, pressing buttons and whatnot. The PLC is still running the whole show of, oh, I need to extend the cylinder for this long and do all these other fun things. But they're not actually like talking back or sending data anywhere. So you can have kind of self-contained little PLC networks, or you can have massive ones that are all networked together, like our little robot station down there. There's actually 5 different Siemens PLCs on that are all networked and talking to each other. This is a combination of both software and hardware, as that video said. Without the hardware, you're not going to get the actual information. You're not going to have the temperature data or pressure or flow or whatever it is. Or you're not going to have motors and things like that to control. And without the software side, you're not actually collecting the data and doing something with it. It's just there. So a little bit of both. The wonderful part here is with current SCADA systems, we have remote access capabilities. Now we do need to be careful with remote access. There's another video that on YouTube that I have on D2L that's called, I think, Honey, I Hacked the SCADA or something like that. And it's all about this, I don't know, security company created a fake power plant where they were trying to get hackers to come in and attack it so they could see how they were attacking, what they were trying to do, what were they doing, and all those things. And one of the things they mentioned in that video is how older hardware was never really meant to be on the internet, but yet it is. Because for ease of my life, right? As the operator of the plant, I need to be able to access this off the book whatever system. Well, it has a serial port on it, which I can connect to it through. Well, if I buy this adapter, I can go from serial port to Ethernet, and now I can access the computer. So we've just taken this device that is in its own mind secure, but now putting it on the internet makes it super insecure because it was never designed for that type of environment. It was never anticipated that, you'd be able to access this thing from China. Like, no, I expect you to be sitting right next to the thing to access it. So the security side here is definitely a very interesting one. I'd suggest watching that video. It is a little on the long side. I think I watched it at 2x speed most recently, and I don't think it was too fast. But that's something to think about. But anyway, we do have local and remote access capabilities if you have things set up right. And again, this also comes down to your IT company. We're just talking about networking before we started this section. And as I said, you're going to be setting up some network stuff maybe, but most likely your IT person is going to do the heavy lifting there. Same thing if you want to be able to remotely access stuff. You're going to have to talk to your IT company. Because they're going to go, you want to do what to our firewall? No, we're not opening that port. And it's really interesting. I have my cousin's husband. He's an IT person, and he's the one that's in charge of opening firewall ports up and doing this and that and testing and all other fun stuff. And he's like, I have to constantly tell people no. To the point where people needed access to servers for copying data or whatever, but they had GUI, like you could log in remotely and like use a mouse and keyboard and like click on things on Windows. And they were doing things they weren't supposed to be doing, so he just disabled the GUI. So now they have to use the command line. They can still do all that stuff, but they now have to know how to do it, not just like click buttons. So it added infinitesimally small level of security, but it was enough to keep the servers more secure because people weren't doing things they weren't supposed to be doing. So a little bit of give and take going on there. Scada does allow real time as it's soft and logging. All right, logging is probably one of the more important aspects. It's amazing what you can see from a little bit of data over a long time. You know, the trends you'll see of those types of things. Yeah, it's just something that you need to kind of keep in the back of your mind. So, who is using this? Basically everybody, including me. I have a home automation system running at my house, and arguably it is Scada. I have control. I can turn my devices on and off from here. I can do it from my phone. I can do it from home. I can see the temperature trends. So over the past, I don't know, as long as the system's been running in its current state, you know, I've updated a few times, and every once in a while I lose all my data. But in its current state, I have access to all of the temperatures from like, you know, probably 4 or 5 months ago at this point, and I can see them over time. So. But yeah, basically everybody is using Scada in the long run. So this could be for maintaining the refrigeration systems at local supermarkets. You know, you have how many freaking refrigerators and freezers and cool sections in supermarkets where all the fruit is and whatnot. Even probably, I don't know if they still do this. I know they used to. Have the little sprayers on like the fruits and vegetables. They used to have that water misting system that would just shoot some water out every so often. That would probably, yeah, that was an automated system. That could have just been like a simple timer on a water hose type of thing, but most likely it was a little bit more than that. So that type of thing. Refineries for oil and gas, for ensuring the production and safety that they're expecting. Quality standards for wastewater plants. Energy use at your home. All right, you could also argue with data. Now, locally, they're not really doing this. I know my electric meter here in town, they actually, every other month, walk up to it and check it, which I find to be very annoying, but that's how the game is. And they actually just put a new electric meter in my house, like, I don't know, 4 or 5 months ago, within the last year. And I looked at it and I was like, okay, because the old ones they had on the check, and I'm like, oh, is this one transmitting my data? And for me, that'd be exciting. For most people, like, wait, that's wirelessly just sending my information out? Like, you want to know my power usage? That's fine. Go ahead, find my power usage. I really don't care. And you know, you could argue that if someone's tracking your power usage because it's being wirelessly transmitted, they will know when you are and aren't home based on energy patterns. So you could argue it's still a bad thing. But I was all excited because I'm like, oh, now I can start bringing that data into my home automation. I could check it every day or whatever and say, okay, you know, today I've used this many kilowatt hours. Right now I could walk out my back door and go read the meter every day, but that's a little bit annoying to me. So not really high on my list of things to do. And there are other things I could buy, but I was just like, well, if this is broadcasting information for free, I'm all about collecting the data. I love data. I actually have an Excel sheet that has every one of my electric bills, basically since we bought our house. But how many kilowatt hours we've used each month. Now, every other month is an estimate and an actual. So I then average 2 together. You know, I combine 2 so I get an actual for 2 months, not 1 month. But I still have all that data. I like data. Anyway, so Scada systems allow for a significant savings in time and money. That's what it comes down. The money could be, well, I have 1 person working instead of 10. Right? We go back to that video, which we're going to come to in a few minutes. Everything used to be done by hand, right? It's like, all right, we load this thing in, we push the button to start it, the heater turns on, we push the button to stop the heater. You know, everything was manually controlled. Nowadays, you walk into a room and the lights turn on. So, a little bit of give and take going on there. But anyway, so that we could do. It could also just be in, again, having better quality control. You know, consistency is key. You buy a bottle of whiskey or whatever, shampoo, Sprite, whatever the case is, you want that to taste like Sprite whiskey hope you don't want it to taste like shampoo, but anyway, you expect it to taste the exact same as the time before. Well, when you're manually doing things, things get off, right? You bake a cake. Your cake is not exactly the same every time. My best example here is like making pizza dough. Like, okay, here's the recipe. And the recipe that we use to make pizza dough doesn't have use 4 cups of flour. It's add flour until. It's like, okay. So, you add flour, you're like, I think that's where I want it. The same thing can be said with a spatula recipe that my wife and I have from my parents. It has a number of flour in it, but you do that, and one day it's super thick, and the next day you do it, and it's like, I need to add more flour. So, like, what's changed? Well, I measured by cups. All right, maybe weight would be a better option. Maybe we should start weighing everything. I think some places actually do weigh everything for their recipes, not do it by volume. Kind of interesting. But anyway, yeah, and there's been lots of case studies that have highlighted the benefits and savings of using modern Scada solutions. So definitely is going to be an important one there. All right, so as the video talked about, Scada first came around in the early mid-20th century. And again, this relied on people manually controlling things before Scada. It was push the buttons, turn the dials, flip the switches, put stuff in, take stuff out. It was a very heavily human-operated thing. Not that that's bad. There are still many times where a human is a better thing than a robot. Right? Anytime you have something that involves very fine dexterity, like lining things up, hand-eye coordination, humans are better. Right? An example, up at the Volvo, just north of here, right? They're assembling engines there. Every engine is different than the one before. They are not just mass producing, this exact model engine. No, every engine is built to a customer's purchase. So trying to program robots to do that is very difficult because this one has 6 bolts, that one has 8 bolts, this one has a turbo, that one has 2 turbo, whatever the case is. Very difficult to get a robot to be programmed to be like, oh, I'm working on this engine. I need to move my bolt pattern to this or to that or whatever. Is it doable? Yes. But they would have to program every single combination of every single engine block. And it starts to become ridiculous. So they actually have humans doing the assembly. The engine is actually on like a moving car. Like a little robot that drives the engine that's not around. The humans are actually working on it as it's moving. It's just, to me, it's kind of nuts. So. But anyway, as industrial floors and remote sites began to scale out in size, they needed some way to control equipment over long distance. And this is when relays and timers started to come into hand. So this is the early to mid-20th century. So we have a little bit of supervisory control, but not a lot, right? It's all right. I need to cook this thing for 30 minutes. Set a timer for 30 minutes. You can walk away. So we have a little bit of supervisory control. We don't have any data acquisition, though. We're not pulling any of that back. So this is just the SCA part of Scada, not the DA part. And relays and timers did solve a lot of problems. It allowed us to start to automate things a little bit. Okay, now we're going to get consistency here. Anyone know what the first programming device was?
Programming device?
What was the first thing someone wrote a program on? It's called a punch card. You literally had cards that had a whole bunch of different holes, and you would punch out the holes that you wanted. That would do certain. And then you would feed this into a computer, and there was a whole bunch of limit switches that hang down, and you'd feed your punch card in, and certain limit switches would be, extended, the other ones wouldn't because they'd be hitting the card. And that would tell the process, extend the cylinder, and then it would advance that thing forward 1 notch. And then it would go, do this, So they actually would put just holes in a card, and that'd be their programming. And again, that was automation. That was automating the system, and that was using relays and timers and things like that to do that process. But it wasn't an actual computer sitting there. The problem with relays and timers, they're difficult to reconfigure. Right? Anything hardwired sucks to redo. Let me tell you, back when I was in my undergrad, I loved that class. Like industrial process control or something along those lines. but we had a board. I have examples of them somewhere around. But it had contactors and limit switches and push buttons and all that stuff just bolted to this board, and you had to hand wire everything up. And you're like, okay, so the first thing you had to do was create your wiring diagram. Then you had to actually wire it. And the best part about this was every wire was red. Every single wire. So when it came time to troubleshoot because something didn't work, you're like, okay, where is it? And you start like trying to like trace wires, and since they're all red, you're like going over and under, and hopefully you follow the wire from one point to the next, and you were able to figure it out. But like, yeah, that was it. And you'd literally have, control cabinets, like the size of the TV or bigger, 8 foot tall, 8 foot wide control cabinet, which was wires and wires and wires and wires leading everywhere. And again, like an actual control cabinet, they might all be white because the wire they used. Now, hopefully they numbered them. So you would be able to go, oh, this is wire number 2, and then you could go find wire. That should connect to this relay. You go, there's wire 2, hopefully. Not necessarily. But when something changed, your process, it's like, okay, we need to make this happen for longer or turn the conveyor off sooner or whatever the case was. Now you had to physically unwire things, wire stuff back together, and again, hope you got it right. So they were a pain to reconfigure, a pain for finding faults, and they took up lots of space. Okay? So early 1950s, that's when computers were first developed for use in the industrial control process, and that's when Scada started to become popular. And this was mainly used for utilities, oil and gas pipelines, and other industrial markets at the time. Not everybody, like we had on previous. So we starting to build it up. Now we got the 1960s, and we have telemetry now. So we're now able to start sending data back and forth from places to places. And so we're able to take communicate measurements and other data from remote sites to monitoring equipment. So we're actually now sending data long distance. The process constantly is getting better and better. In 1970, that's when Scada was I'm going to call it termed or used. And this is when microprocessors and PLCs started to increase and rapidly. Once we had PLCs, so PLCs, programmable logic controller. I love how the video is like, as you know. So I'm like, the first video we're watching this class. I don't necessarily know what a PLC is, but PLC, programmable logic controller. That has basically replaced all of the wiring. Right. So instead of having button A connect to button B, connect to limit switch C, connect to proximity D, connected to relay, connected to out, whatever, we have all of those connecting to the PLC, and in the PLC we write our code. We basically draw our wiring diagram. So that way when you need to change something, you just have to drag a few symbols around, and Bob's your uncle, you're good to go. So yeah, it makes life so much easier having a PLC on board. All right. So back to the beginning of Scada. Everything was, as this says, monolithic, which means it was all by itself. So everything, you had a Scada system, you're like a little conveyor, a little assembly line over there. That would be one system. It would be all self-contained and all over fun things. So we didn't have any networking back then. So actually, it'd be even smaller than that because we have 5 different PLCs on that thing. Now, could we run that thing off one PLC? Yeah, we could run that off one PLC. It's just nice to separate things by sections. It makes your life easier. Especially when we had to move that thing over here. We were able to divide it into three different groups, and we would roll them over separately instead of having to, if we had them all in one PLC, we'd have to try to move that whole thing at once or unwire every sensor and everything that goes between units. So being able to do it all separately was definitely a lot easier. So everything stood on itself. This was referred to as monolithic Scada system. In the 80s and 90s, we started having networking is introduced. We started having smaller computer systems. We have local area networks now, not necessarily based on Ethernet. Right? Coax used to be our networking system with token ring and things like that. We're going to come back and talk about that. Maybe next class or next week, one of those two. So we did have local area networks connects then, and then we also had PC-based HMI software, the human machine. Now able to actually start looking at that data on a nice graphical screen. HMIs are absolutely wonderful. PLCs, the bomb. HMIs, close second. Because HMIs allows you to show the operator lots of information. Instead of, if the PLC detects an error, you could just flash a light. There's a problem. The HMI can go, error 32, and you'd go, what's error 32? And you're like, oh, sensor malfunction. Okay, I now know. Where if you want to do that before without an HMI, you had to have an error light for every different number. So if you had 100 different error codes, you'd have to have 100 different outputs for each light. That's a whole other PLC's job, basically, to have that many freaking outputs. HMI allows you to go a lot more detail. Basically, especially HMIs today, we have Ethernet cables that go from PLC to HMI. So you have one wire for power, one wire for communication, and you're done. So you don't have to have one output terminal for every frequency. Makes your life a lot easier having those HMI. And at this point, we're starting to be able to connect to other similar systems. Now, we did have proprietary networking protocols, and this is still somewhat of an issue. Communicating from like Siemens to Allen Bradley, or ABB to Siemens or Allen Bradley, whatever the case is. We still do have some of that communication. Yes, basically they all have Ethernet ports on them, which means they can all be on the same network. But still communicating from them is kind of a pain. It's like communicating from a Mac computer to a Windows computer. It can be done, but it's not always the most reliable or easy to set up. Once you kind of get it set up, you're normally good. Sometimes you need to have like a protocol, modifier. So it actually, company A makes this, and they say, I can take Siemens information in, reconfigure it, and shoot Allen Bradley information out. My mom used to work for a computer company. And when, they would lose a client, they'd be like, okay, we need all of our data. And my mom's company would be like, you have your data. It's on the server in your office. But we can't read that. It's not our fault. Like, your data's there. If you want your data in a format that you can be importing it into your new software, you have to either pay us for it or pay them to write the comment, the modify. Type of thing. Yeah. We store it in this format because of our, I don't know if it's wasn't proprietary. Again, it was probably like plain text, comma separated, some sort of simple, file. And all their data was technically on their server. The company wasn't hiding it; it was there. They just had a way to access it anymore because they stopped paying for the service. So it's definitely a little bit of a money grab, all these proprietary systems. At the same point, especially back then when it first started coming out, was our system, we're developing this because it's the best option for us. This way we can communicate most efficiently from one device to another using the lowest network overhead, all those other fun things. And Siemens went, no, we can do it better. Allen Bradley, no, we can do it. So yeah, it's still a pain. Anytime you're trying to integrate things that aren't meant to be integrated in. These systems that could talk to their own types, but not other companies, were called distributed Scada. So we had monolithic, now we have distributed. And in the early 90s and 2000s, this started getting us to the open system architecture. Right? Kind of thinking about more like open source, right? Where it's like, okay, we'll talk to you. We're going to use this system. I am a big fan of standardized. Every cell phone, as far as I'm concerned, should use USB-C power delivery. The fact that Apple doesn't do it pisses me. And Apple's like, but it's going to keep us from developing and making new hardware and things like that. It's like, you kind of understand that. I mean, like, they had the old Apple big flat connector, and that how audio out and control and all those other fun things. Good for you. Like back then, there was a reason for it. At this point, I don't think the Lightning connector does anything special that the USB can't do. So that just bothers me. But that's a story for another day. So yeah, not vendor specific. This is called Network Scada now. And they're using base over Ethernet. Yep. And then the technology boom occurred. This is when personal computers and IT technology accelerated. Right? And this is kind of where we are today overall. And IT took over, right? It used to be like, oh yeah, you have your industrial network equipment, they're all going to talk together, you're going to have your own little probably specialized network, you're going to have maybe your own special server where all the SCADA and information is collected together. And IT kind of came in and said, we're going to take over that now. Or we're going to support this system, not that system. That's when SCADA went, no, we don't care. We're just going to keep doing our own thing. That's where that rift occurred. And this is where SCADA started to become antiquated, started becoming outdated, because they weren't keeping up with technology. As we all probably know, or if you don't know, I'm going to tell you now, technology is outdated the day you buy it. I don't care if that graphics card was just released today. It's already outdated. Because they're already developing the next generation, right? It's like the next generation card might even already exist as a prototype somewhere, so the card you just bought is outdated compared to that new one. It sucks. You know, technology is changing so rapidly that it is hard to keep up with it. I mean, you kind of have to study constantly to keep up with all the changes that are happening. Bit of a give and take going on there. So yeah, definitely need to kind of keep up with that one. Traditional SCADA systems still use that proprietary technology to handle data. Modern SCADA systems use, modern SCADA started implementing that SQL. Talking about SQL. You ever hear it called SQL? That's SQL, structured query language. That's what it was. Structured query something. But we started now actually. So modern SCADA, we have real-time data access. Right? I've never been at a plant where you have a room like this where you can walk in and see what's happening everywhere at any given moment. Right? Just thinking about that kind of blows my mind. There are hundreds of thousands of millions of companies out there that are doing this. And walking in and having that type of control is just a little ridiculous to me. So we do have real-time data access, and this can be local or remote, as the video talked about. You could hop on your iPad from wherever it is you are and be like, okay, let me see what the plant's doing. Is there any real need to do that? In my opinion, no. Large corporations, yes, they want to be able to monitor everything. Right? You go on vacation and you're the supervisor and something happens. Well, you can jump on your iPad and look at what's going on while you're on vacation now and not have to maybe be flown home or the company just be out of luck until you get back. So there is a lot of benefit to be able to have remote access. Think about it, right? As schooling has become now, we can teach this class online. Like I could have done this whole class online. Obviously recording it right now for somebody else. The hands-on stuff, that's a bit harder to do online. I mean, I could have made a little kit and sent you guys all a hunk of Ethernet cable and a crimper and connectors and said, here, do this. When you're done, mail it to the next person. And you just kind of pass the equipment around. That wouldn't have been too big of an issue. At least in this class, it wouldn't be. But you start getting into like the bigger stuff, like my robots and things. That's a bit harder to just mail, but you can come up with some systems. But like our ABB robot, we can virtualize it. We can simulate it. And I did that one semester when COVID started. Okay, I'm online. Got to come up with a way to do this. And use the simulator. Getting it set up on everyone's computer was the biggest pain in the rear end because it was just, okay, you're having this problem. I had to Google what the problem was. Okay, try this, and those types of things. This person didn't have the best computer, so they ran really slow. And, it was just not a nice experience, guys. But we could do it. Once IT and SCADA merged, we now have that SQL and web-based applications. Also, as you guys hopefully know, I hate this. Everything's going web-based. Web-based and subscription-based. I hate. Okay? I hate that I have to have an internet connection to use a piece of software. That just seems ridiculous. I'd much rather just be like, nope, it's downloaded, it's installed on my computer. If the world goes to hell, I can have my computer and not have internet, and I can still use the software. Call me crazy, but convenient. The whole web-based thing is convenient because you don't need the powerful of the computer to run it because you're just doing it in a web browser and all that powerful processing is happening in the cloud somewhere. So there is definitely a give and take going on. Subscriptions, I also hate. You guys, that's just a money grab if you ask. We just want more money out of you. My best example, I don't know did I tell you guys about the whole remote starting cars thing? Yeah, one company, I forget who it was, you had to have a subscription to remote start your car. And when you first bought the car, you had like 3 years for free, and that 3 years is now up. So even if your car remote has the remote start button on it, you can't press the button to remote start your car unless you're paying for the subscription. And I understand if you use the app. Okay, I'm going to use the app, which means I now need to have that wireless connection to my car, so I'm using a cellular modem in my car to do it. I understand that aspect. But when I'm going from my remote directly to my car, there is no need for me to have a subscription. Luckily, I do not own that. I'd be very upset if I did. But, yeah. Oh, yeah. No, it's nickel and diming you. And to be fair, if you pay for Pandora or Spotify or Amazon Prime or Netflix or Apple, whatever, you're part of this. Because instead of buying a movie outright, spending the $20-30, you're saying, okay, I'm just going to give Netflix $10 a month and I can watch as many movies as I want. So you're paying a subscription, but you get access to this large database, and you're going, I don't need it all the time. I'm right there with you. We have Netflix, we have Amazon Prime. It's like, okay, that aspect, I'm okay with it. I'm not thrilled, but you're like, okay, I'm going to watch 5 seasons of something or 6 seasons. It's like, well, there's $50. It's like, well, that's a half a year's worth of subscription. And if I'm watching that, my kid wants to watch this, and my other kid wants to watch this, now you're $300 in the hole for the year, where if it's just a subscription, you're $100 in the hole. So a little bit of give and take going on there. But anyway, now that we're starting to use, hold on. Benefits of that IT and Scada merge. Efficiency, so we have less work that has to be done for getting information from point A to point B. Higher security, because again, now we're relying on the IT infrastructure. We're not saying, okay, we have to secure this whole separate system. We're saying the robot sends information to the server, the SQL server on the IT network, and the IT network can allow remote access or deny it based on IT rules. So that's awesome. Reliability is up because we're not relying on older technology anymore. Now, I do say anymore, right? There are still old SCADA systems out there. Right? There's nothing I'm going to argue against that. But yeah, so something to think about. Yeah, okay. So anyway, SQL's kind of the key there. So here I just have a little picture. It's showing you all the kind of how things would be roughly connected. So you've got sensors connected to PLCs or RTUs, which connect to other PLCs and RTUs, which connect to HMI or SCADA panel views and other manual inputs. The list kind of goes on and on, but everything is kind of networked together in somehow, some way. So all of these, pen out. So all of these sensors, really, not gonna let me draw. Let me draw? No. Oh, thank you. Hey, now I can see it. Can I draw over here? Oh, that's wonderful. Okay. I just love it. I'll do it the other way. Fine. All of those sensors, all right, up in that top corner there, those are all going to, as I said, sending data to the PLCs. Same thing with all these manual inputs down here. They're going to be sending information to these PLCs. So even though we've got dotted lines, everywhere, it doesn't all mean the exact same. All right. All these sensors, those are going to be individually connected to a PLC. All right. So every sensor, this would be input 1, this would be input 2, 3, 4, 5, 6, et cetera, et cetera. So they'll have their own input on the PLC. And that PLC is what's actually sending that information to that SCADA system. And one thing I would argue is missing from this is, why can't I draw? Is the server. Right, that's going to be connected here as well. So all that data is getting sent to that server. That server is then maybe sending stuff out to the SCADA panels or whatever else the case. So I would say we are missing a big ticket item in this instance here. All right. So how does this actually work? So the process. Data is transmitted from the sensor. All right. And that's going to get passed to processors such as a PLC or an RTU, as we've talked about. After that, that data is then distributed to a system of network devices. And this could be directly to the HMI. Most likely, HMIs are directly connected to your PLC. They're Ethernet connection, and you have you've programmed your HMI just like you've programmed your PLC. And in fact, in the world of Siemens, you do it all in the same exact program, which I love. Right? You go to Allen Bradley world, and it's like, oh, PLCs use this software, HMI use this software, this other PLC uses this software. It's like, oh, you got it. However, and that nice, the benefit of having all those different softwares is all the software is actually a little bit easier to use. It's not a Swiss Army knife, right? It doesn't do everything. It does one thing. When you do something else, use another piece of software. It's not the Swiss Army knife. That aspect I do like, Allen Bradley. So this could go to HMIs, it could go right to your user computer, or it could go to that SQL server. Or it could go to all three, right? Because the server is the one that's doing the data acquisition and storing it long term. The HMI is showing the instantaneous values, and your computer, I don't know, doing a combination of both, maybe. Seeing instantaneous, allowing you to control things, whatever the case is. Once we have all that data, we now start to make GUIs. All right? I've used the word GUI already today. What does GUI stand for? It is a graphical user GUI, G-U-I, graphical user interface. There you go. All right, so you can read my handwriting, hopefully. So graphical user interface. Windows is a GUI, right? You have this beautiful picture in front of you. You can use a mouse to click on things. Touchscreen nowadays, your phone. Before GUIs, we had command lines. That was how we interacted with it. So you just had a keyboard. You didn't have a mouse at all. I was just having this conversation with my wife the other day. Like, why is the number pad on the right side of the keyboard? It should be on the left side of the keyboard, in my opinion. Because if you're doing something and you have your hand on your mouse, your other hand can be on the number pad very easily then and be more comfortable if it's on the left. Well, before mouses, we had terminals, you had command lines, you didn't have your hand on the mouse, so having the number pad on the right, where your probably more dominant hand was, probably made more sense. For me, now I want it on the left. My wife's like, but I wouldn't be as good at using it. It's like, you get used to it being on the left, right? It's one of those things that the more you would use it over there, the better you are. It's like, you can really quickly type out numbers with your right hand now, because that's what you're used to. Start doing it with your left hand, you'll get pretty proficient. But yeah, so like gaming. We use WASD for going forward, back, left, and right instead of the arrow keys, because I think of where they are on the keyboard and what's around them. Maybe the arrow should be on the left side too. I digress. But anyway, so anything that has a nice picture, has a screen that is not just text, that is a graphical user. And these can go from being very simple, which is just like a few buttons that you can tap with your finger, to being buttons with things that are moving on the screen to show you that the motor is running, or the temperature, or the sensors going up or down, whatever the case is. I've made a GUI for one thing that like the temperature change, the color changed based on the temperature of something, and the package moved along a conveyor belt, and all of the wonderful fun things. A lot of options there. So the graphical representations of the operations exist for operations interactions such as running pumps and opening valves. So just saying, like, you can create a little graphical GUI that says when the motor is spinning, the wheel shows motion somehow. Changing colors, black to gray to black to gray. It kind of makes it look like it's like this or whatever. Or if you have a rotational, you have every other thing being a different color, so you can see it physically spinning around. So we can do things like that. We can also do troubleshooting problems, as I mentioned earlier. You could say, error code 32, instead of just saying, well, the error light's on. I have to get the computer out to plug into the PLC to figure out which exact error code. All right, so having that graphical interface makes our life a lot easier. And the one thing that you might ask, probably not going to ask, but PLC versus HMI, or not HMI, versus Scada. And the key here is it's not one or the other in this. All right, it's, well, you either have a PLC and you're using Scada with it, or you don't have a PLC with Scada. Scada isn't replacing the PLC. That PLC is still the important process. It's still gathering all the input. still actually controlling the outputs and all those other fun things. But the Scada is the software that's interacting. Not necessarily your code. All right, you can still program the PLC without Scada, just saying like, when this happens, do this. When this happens, do this. You know, yada yada yada. But the Scada will allow us to now maybe take over, make manual control, or tweak timings or things like that on the fly, which will make it a much more enjoyable experience to use per se. The Scada is also collecting the data for historical purposes. So Scada may be what's controlling the PLCs, but it still needs data from the PLCs to work. So it's not Scada or PLC. It's kind of a combination of both of those at the exact same. All right. Any major questions so far? Guys, we're pretty quiet. Not too surprising to me. All right. Let me go ahead and we can pull this. There we go. Now I don't like this. All right. Anyway, let me just go ahead and stop recording them.